This is the Architect Exam Podcast, the official podcast of the Young Architect Academy.
Hey, welcome back to the Architect Exam Podcast. This is Layla, and I'm so excited to talk to you about one of my favorite topics, which is means of egress. When Mike asked me what topics I wanted to discuss on the podcast, and I said, I want to talk about egress without even hesitating, he probably wasn't surprised. If you've taken my Building Codes 101 course at the Young Architect Academy, you know I can talk about egress all day. There's a reason I dedicated a whole module on this topic. I know what you're thinking. Really? Egress is your favorite topic? Yes. And at the end of the podcast, I hope that you'll share a little bit of my enthusiasm towards this subject. Because here's the thing. Means of egress isn't just about memorizing a bunch of code requirements. It's really about designing buildings that are safe and can potentially save people's lives in an emergency. This is going to show up all over the ARE exam. You'll see egress questions in both PPD, your Project Planning and Design exam. You'll see it in PDD, your Project Development Documentation division. You're going to also see it likely on your Programming and Analysis exam. So mastering all these topics are going to give you a serious advantage. When I was taking the technical ARE bootcamp, means of egress was one of the topics that clicked for me once I really understood the logic behind it. Now, I love teaching it to the boot campers and seeing their aha moment that's similar to what has happened to me. Today, we're going to try to break down this topic into bite-sized pieces that will not only help you on your exam, but really make you a better architect. So let's just jump right in. Since this is a podcast and you're probably driving to work right now and can't write anything down, I already wrote a quick set of notes for this podcast. You can download a 2-page PDF study guide with everything I'm discussing today. Just if you go to youngarchitect.com/egress. First things first, what exactly is means of egress? You want to think about it as the emergency escape route from any building. It's the path that's going to get people from wherever they are in the building and outside to a safe place. But here's the key thing to remember. A means of egress isn't just one thing. It's actually made up of 3 distinct parts that work together if you think about it just like a relay team that's passing a baton. The first part is called the exit access, and that's basically everything you travel through before you get to an official exit. Think about it, the path, let's say from your desk to the stairwell door in an office building. You might walk through your cubicle area and then down a hallway, maybe past the break room. All of that is your exit access. So it's really an access to the exit that you're trying to reach. Now, the second part of the means of egress is called the exit. This is going to be a protected portion of your escape route. Think stairwells with fire-rated walls. That would be an exit. I like to think of exit as a safety bubble inside a building. Once you're in an exit, you're in a protected space designed to stay safe even if the rest of the building is compromised. And in most buildings, the enclosed stairwells are the primary exits. Now, our third component and the final component is the exit discharge. And this is going to be the path from the end of the exit that you've reached to the public way. And usually think of the street of an open public space. Imagine you've come down the stairwell and out the door at the bottom. Now you might need to walk across a courtyard or down a sidewalk to get completely clear of the building. That final stretch is the exit discharge. So let's review. We have the exit access, then we have the exit, then we have the exit discharge. Think of it like a journey that you're taking from danger to safety. First, you're going to make your way to a protected route. Then you're going to travel through that protected route. And finally, you reach the outside world and get clear of the building. And on the ARE, you're going to need to identify these components on floor plans and understand how code requirements apply differently to each piece. Let's talk about the secret sauce of egress design, which is occupant load calculations. In our Building Codes 101 course at Young Architect Academy, I always emphasize how code analysis begins with understanding occupant load. It's the foundation of so many design decisions. So occupant load is not just a number of people a space is designed to hold. This is super important because it drives almost every egress requirement. Think of occupant load as how many people are going to need to escape number. It determines how many exits you're going to need, how wide they need to be, and a bunch of other requirements as well. Now, how do we calculate the occupant load? You take the area of a space and divide that by a factor that depends on how the space is used. So it's dependent on the function of the space. Let's take a real world example. Let's say you have an office building and it's 3,000 square feet. Now, the factor, if you go to chapter 10 of the IBC and you look at table 1004.5, you're going to see that for office buildings, the occupant load factor is 150 square feet. So I have 3,000 square feet of office space, and I have the load factor is 150 square feet per person. So I'm going to divide that 3,000 square feet by 150, and I'm going to get an occupant load of 20 people. But what if the same 3,000 square feet was an assembly space with chairs only? I'm going to go back to table 1004.5, and I'm going to look at what is my occupant load factor for an assembly space with chairs only. So I'm going to find that that's going to be 7 square feet per person. So now I take the 3,000 square feet that I have, divide it by 7, and I'm going to get 428 people. Now that's a huge difference depending on the function of the space. I like to think of these as your personal space bubbles. In an office, you get a big bubble of personal space. Now, at a standing room only concert, it's going to be a tiny bubble. It's like architects are legally enforcing the personal space that introverts have wanted all along. Now, once you have your occupant load, you can determine how many exits do I need. Generally, the key number here is 49 occupants. If you have 49 or less occupants, you can have one exit. Now, when that occupant load reaches more than 49, so if you have 50 or more, you're going to need 2 exits. You don't have to memorize, the occupant load and how many exits you're going to need. There's a table in the IBC for that for you to reference. However, this number is really important to memorize. It's good not just for the ARE, but for your practice as well. So general rules of thumb. So think about it. I'm good with 1 exit if it's 49 or less. Once it's 50 occupants, I'm going to need 2 exits. Now we also want to look at how wide should my doors be. A rule of thumb is you multiply the occupant load that we just got by 0.2 inches per person. Now, these are the numbers, the multiply factors that are for if your building is non-sprinklered. How wide are your stairs going to be? You multiply the occupant load by 0.3 inches per person. So to easily remember this, I like to think about, how can I remember that doors are going to be 0.2 and stairs are going to be 0.3? I think about it, doors are the first step to getting into the stair. So that's going to be going 0.2, and then you reach the stair, that's 0.3. So it's a larger number. Now, I mentioned that these factors are for building without a sprinkler system. Now, what happens if you have a sprinkler system? Now, you're allowed to have smaller doors and less wide stairs because of the extra safety that's added with your fire suppression system. So your doors go from 0.2 to 0.15 factor, and then the stairs go from 0.3 to 0.2. Let's do a quick door width example here. Let's say you have a restaurant that has 300 people. So you multiply, to get the door width, you multiply the 300 people by 0.2, which means you're going to need 60 inches of total width. That might be 2 36-inch doors. Now, the ARE does love to test these calculations, so make sure you've got these down.
You're listening to the Architect Exam Podcast, your guide to passing the ARE.
Now, let's talk about the nitty-gritty physical requirements for egress components, the stuff that shows up in almost every ARE question about egress. And we're going to start with doors. Egress doors have to be wide enough for people to get through quickly, including people in wheelchairs. The magic number here is 32 inches of clear width when the door is open at 90 degrees. So this is something you have to remember. You cannot go less than 32 inches. That is the minimum. Now, a fun fact, a standard 36-inch door does provide 32 inches clear width once you account for the door frame thicknesses and hardware. So they meet this requirement. If you think about it, that's about the width of a refrigerator. So if you can get your refrigerator through it, then your building inspector will be happy, but I wouldn't recommend using that technique. Now, door swing direction is another big one. If you have a space of 50 or more people, the doors have to swing out in the direction of egress. That means it's going to have to swing outward. I always think of this rule in terms of just a crowd pushing on a door. So if you have a lot of people and they're pushing in panic, you want the door to swing in the direction they're pushing and not against them. Now, for hardware, the big thing to remember is you can't require special knowledge or tools to open a door from the egress side. That means no key-only locks, no complicated mechanisms, just simple hardware that anyone can operate quickly, because you want to think that people are going to operate this door in a panic. Now, for high occupancy spaces, especially assembly areas with 50 plus people, you need panic hardware, those horizontal push bars that you see on doors in theaters and schools. Now, let's talk about corridors. The standard minimum width for corridors serving 50 people or more is 44 inches. Now, if you're serving fewer than 50 people, you can reduce that to 36 inches. But there are, of course, always special cases. So if you look at educational corridors serving more than 100 students, they need to be 72 inches wide. Healthcare corridors where they might need to move stretchers, in hospital settings, they need to be a whopping 96 inches wide. I like to think of corridor widths in terms of how many people can walk side by side. For example, if we have a 36-inch door, one person with some personal space can walk through. 44 inches, you can have two people can squeeze past each other. 72-inch width corridor, you're going to have two pairs of people that can pass by comfortably. Now, if you have 96 inches, you can have a stretcher that can be rolled with people assisting on both sides. For stairs, the standard minimum width is 44 inches with minimum tread depth of 11 inches and maximum riser height of 7 inches. So this is really, really critical to remember for your practice and while you're studying for the ARE. I always tell my boot campers to really visualize these numbers. Imagine what a 44-inch corridor actually looks like compared to a 36-inch one. When you can mentally picture these dimensions, you're going to be able to quickly identify whether a design meets code requirements without having to look everything up. Having these numbers embedded in your brain will really help you solve problems more quickly and efficiently on your exam. All right, folks, now we're going to talk about how far people have to travel to reach safety. This is a huge part of egress design, and the ARE does love to test on it. During the ARE bootcamp, this is one of the topics that always generates tons of questions. And I get it. There are multiple measurements that sound similar but mean very different things. There are 3 critical measurements that I want to give you that you need to know. First, exit access travel distance. This is going to be the total distance from the most remote point in a space to an exit. Think of it as the longest possible escape route. Second, your common path of travel. This is the distance a person has to travel before they have 2 separate ways out. I like to think of this as the point of no return distance. If fire blocks your path before this point, you're potentially trapped. Third, dead-end corridors. These are hallways that don't lead to an exit. They're basically, wrong way corridors with a limited allowed length. The actual distance limits vary by occupancy type and whether your building is sprinklered or not. But here, I'm going to give you some key numbers to remember. So for exit access travel distance, for most common occupancies, if we say assembly, business, educational, 200 feet without sprinklers, 250 to 300 feet with sprinklers. Low hazard spaces can go longer, up to 300 feet without sprinklers, 400 feet with sprinklers. Now, For common path of travel, most occupancies are 75 feet without sprinklers and 100 feet with sprinklers. High hazard areas, as you might think, is going to be much shorter, around 25 feet. Now, for dead end corridors, the standard limit, the magic number is 20 feet. You cannot have a dead end corridor of more than 20 feet. That's going to get people trapped in case of an emergency. Now, if you add sprinklers to your building, you can take that number higher to 50 feet. Notice how sprinklers make a huge difference. This is because sprinklers control the fire and give people more time to escape. So when measuring these distances, you follow the actual path of travel, not as the crow flies. So start from the most remote point and trace the natural walking path to the exit. Here's a pro tip for the ARE. When analyzing a floor plan, you're going to find the most remote corner of a space and measure to the nearest exit. And if it exceeds that limit, that means you've spotted a code violation. Now, let's talk specifically about where means of egress shows up on the ARE and what kind of questions you can expect. In the Project Planning and Design PPD division, egress is primarily covered in Objective 2.2, apply building codes to building design. And that makes up 8 to 12% of the division, and that's a really significant chunk. You're going to likely see questions on calculating occupant loads, determining required number of exits, evaluating travel distances, and also assessing corridor widths, that if they're adequate or not. PPD is also going to cover egress requirements that shape the overall building design under Objective 4.1. Think about it. If you need 2 widely separated stairs, that's going to fundamentally affect your floor plan. Now, in the Project Development and Documentation PDD division, you'll find egress under Objective 4.1. Determine adherence to building regulatory requirements at the detail level. PDD questions do tend to be more technical. They focus more on specific dimensional requirements, fire resistance ratings for exit components, stair design details, door hardware requirements. You'll also see egress documentation requirements under Objective 2.3, which covers construction documents. What might you see on that? How to document fire-rated walls around stairs, how to specify door hardware and door schedules, and also how to detail stair sections. A really common ARE question format shows you a partial floor plan and asks you to identify code violations related to egress. They love to include issues like this. Doors swinging the wrong way, corridors that are too narrow, dead-end corridors that are too long, travel distances that exceed limits. My advice to you, when you see a floor plan on the exam, immediately check door swings for spaces that might hold 50 plus people. I would look at corridor widths, travel distances from the farthest corners, and take a look at number of exits based on the occupant load that you have. If you do the systematic check, you're going to catch most egress violations they throw at you.
You're listening to the Architect Exam Podcast, the official podcast of the Young Architect Academy.
Let's talk about some special occupancy types that have unique egress requirements. These absolutely show up on the ARE. First, you're going to look at high-rise buildings, typically defined as having an occupying floor more than 75 feet above fire department access. High-rises have extra requirements like smoke-proof enclosures or pressurized stairwells, fire service access elevators, re-entry from stairwells at certain intervals. I would think about high-rise egress as egress plus redundancy. All the normal requirements, the typical requirements, plus extra safety measures, because evacuation takes longer and is a lot more complex. Health facilities are another special case. The coolest thing about healthcare egress is the concept of horizontal exits. Instead of making everyone go down the stairs, horizontal exits allow patient evacuation by moving them horizontally through a fire-rated wall into another smoke compartment on the same floor. Healthcare facilities also need those super wide 8-foot corridors I mentioned earlier so that you can accommodate for stretchers and equipment. Assembly occupancies like theaters, think about restaurants, have their own special requirements as well. The most important is the main exit rule. The main entrance that people use to enter must be sized to handle at least 50% of the total occupant load. So think about this. Where do people naturally head when there's an emergency in a space that maybe it's your first time in? Typically, they're going to go back the same way they came in. This rule acknowledges this human behavior and designs for it. Assembly spaces also have detailed requirements for seating arrangements, like maximum seats in a row and minimum spacing between the rows. Historic buildings get some flexibility with compliance alternatives that allow them to preserve historic features while still providing adequate safety. The ARE might test your knowledge of when these alternatives are appropriate. Understanding these special cases connects directly to PPD. So if we look at Objective 2.3, integrate multiple codes to a project design. And PDD, Objective 4.2, determine adherence with specialty regulatory requirements. Now, one of the most exciting aspects of egress design is how it's going to connect to all the other building systems. This integration is a huge part of the ARE. Let's start with structural systems. Your egress stairs need support, right? So stairwells create big openings in your floor plates that need special structural considerations. Also, fire-rated exit enclosures require specific structural elements. You can't just use any construction method. The structural grid might even influence where you place your stairs for efficiency. Now, with mechanical systems, there's tons of coordination that's needed. Stairwells might need dedicated pressurization systems to keep smoke out during a fire. HVAC ducts that penetrate fire-rated exit access and exit enclosures might need special treatment like fire or smoke dampers. For electrical systems, emergency lighting along egress paths is really critical. So if the power goes out, people still need to see their way out. Exit signs need to be illuminated and properly placed to guide people. Fire alarm systems integrate with egress by automatically releasing magnetic door holders and locks when the alarm triggers. You'll also need to coordinate fire suppression systems like sprinklers. Not only do they save lives, but give you those increased travel distance I mentioned to you earlier as well. All of this ties directly to PPD Objective 4.2, which is integrate building systems in the project design, and PDD Objective 1.6, coordinate mechanical, electrical, plumbing, structural, and specialty systems. I really love thinking about egress as this connective tissue in a building. It touches everything else and requires holistic thinking, not just knowing like the isolated code requirements. I'm going to share with you some strategic tips that are going to help you tackle means of egress on the ARE. First, for studying, start with Chapter 10. That's the means of egress chapter and the source of most exam questions on this topic. This is exactly why I structured the Building Codes 101 course to spend much time on Chapter 10. Having gone through the technical ARE bootcamp myself before creating Building Codes course, I know exactly what trips people up on exam day. But I really don't want you to just memorize the numbers. Understand the reasoning behind these requirements. For example, why do doors need to swing out fit for 50 plus people? Because a crowd pushing on a door during an emergency could prevent an inward swinging door from opening. I would also create flashcards for key dimensions and occupant load factors. I would think about these as must memorize. Now again, on your exam and in practice, you do have access to the IBC, whether it's excerpts of the IBC or the whole chapters or book, but it's really critical to have some dimensions memorized so that it facilitates you solving the issues and the problems at hand more quickly. For multiple choice questions, really try to look for dimensional violations first. They're usually the easiest to spot. If you have a question that involves calculations, you absolutely need to have your formulas memorized. We talked about occupant load. Your occupant load, you take the area and then you divide it by the load factor that you find in Chapter 10, Table 1004.5. If you have door corridor width, you take the occupant load and multiply that by 0.2 inches per person. If you have a non-sprinklered building, stair width, you take the occupant load and multiply that by 0.3 inches per person. if you don't have a sprinklered building. So those are important dimensions to remember. When reviewing floor plans and case studies, try to be systematic. Check stair placement. Are they well distributed? Verify travel distance from remote corners. Confirm door swings that they match also the occupant load requirements. And take a look at corridors. Do they meet the width requirements? Now, the key dimensions that I really want you to remember is minimum door clear width, 32 inches. Standard corridor width for 50 plus occupants, that's going to be 44 inches. Healthcare corridor width, 96 inches. Educational corridor widths, if you have 100 plus occupants, that's going to be 72 inches. For stairs, your maximum riser height, 7 inches. Minimum tread depth, 11 inches. These numbers show up again and again on the exam. So if you know these by heart, you're going to have a really good advantage on the exam. You might even start correcting corridor widths at, like, let's say, a restaurant, because, nothing says fun dinner conversation like telling your friends why this hallway doesn't meet code requirements. So we've covered so much ground today, so let me wrap up with the key points that you should take away. Remember 3 components of egress. We have exit access, which is the path to an exit. We have the exit, which is the protected portion of the egress path. Exit discharge, the path from the exit to the public way. Remember that occupant load drives almost everything in egress design. Know your factors and how to calculate loads. Know where the tables are in the IBC for these calculations for the different occupancies. You also want to know your standard dimensions by heart. Door widths, corridor widths, stair dimensions. These are, in my opinion, an absolute must for the exam. Understand travel distance measurements, exit access travel distance, common path of travel, dead-end corridor, and all the different limitations based on whether your building is sprinklered or not sprinklered. Remember that special occupancies do have unique requirements. So high-rise buildings, healthcare, assembly, historic buildings all have their own unique special egress considerations. And finally, think about egress as an integrated part of a whole building. It connects to structure, it connects to electrical, mechanical, plumbing, and specialty systems. On the ARE, egress appears prominently in both PPD and PDD divisions. If you see it in PPD, it's really about applying requirements to overall building design. In PDD, it's about detailed compliance and documentation. But really beyond the exam, understanding means of egress is about designing for safer buildings. As architects, we are responsible for creating spaces that protect people, especially during emergencies. I really hope that this helped you see why I'm so passionate about this topic. I don't think about it as just code requirements. It's literally designing to save lives. I know what you're probably thinking. Layla needs to get out more if egress is so exciting to her, but just wait until you hear my podcast on fire sprinklers. Thanks so much for listening today. If you found this helpful and want to dive deeper, check out our ARE 101 course at the Young Architect Academy. I do break these concepts down with visuals, practice questions in the Building Codes 101 course. Or you can join us in the next Technical ARE Bootcamp where we'll coach you through the entire exam process over 10 weeks. Just go to youngarchitect.com to learn more about that. But before we wrap up, don't forget that I've created a 2-page PDF study guide that summarizes everything we've covered today. You can get your free study guide at youngarchitect.com/egress so that you can keep these critical concepts at your fingertips while you're studying. Keep studying, keep designing, and I'll catch you at the next episode where we'll tackle another critical ARE topic.
Thanks for listening to the Architect Exam Podcast. Ready to take your studying to the next level? Visit our online ARE Architecture School website at academy.youngarchitect.com to learn more about how we can help you. See you next time.